Okay, in this problem, we're asked to find V0 using Thevenin's theorem. And if we look at our circuit, V0 is a voltage across this element. We're going to utilize a problem-solving strategy entitled AC steady-state analysis and then applying Thevenin's theorem. And if we look at the strategy for Thevenin's theorem, it says remove the load. Okay. Since we want the voltage V0, this is going to be our load that we're going to remove. We'll make a couple of terminals A and B. And what we're going to do is we're going to calculate the open circuit voltage, the Thevenin impedance. Once we have those, we're going to come back and hook up the minus J2 ohm and calculate the voltage V0. So our task then is to find the open circuit voltage and the short circuit current. And the issue that we have here is the fact that we have a dependent source. So first, let's find the open circuit voltage. So now we're going to remove our minus J2. There's our circuit, and we want to find the open circuit. Now, it'll probably be easiest here to use mesh analysis, so let's define mesh currents. Once we have the currents, then we can apply KVL around this loop to find that voltage. So let's start with the mesh on the top. We have 4I1 prime plus J4 I1 prime plus J2 times I1 prime minus I2 prime is equal to 24 at an angle of 0. So this becomes 4 plus J6 I1 prime minus J2 I2 prime is equal to 24 at an angle of 0. So here's one of the equations that we're going to need to solve. Since we have two unknowns, I1 prime and I2 prime, we're going to need two equations. Now, let's work on this mesh. We'll have 4 I2 prime, which is a drop across this resistor. We'll have J2 times I2 prime minus I1 prime plus 6 I2 prime plus 2 VA prime equal to 0. Now if we look at our circuit, here's our controlling variable VA prime, and if we look at the orientation of voltage in this current, VA prime is minus 4 I2 prime. So now let's substitute in. So we'll have 4 I2 prime plus J2 times I2 prime minus I1 prime plus 6 I2 prime minus 8 I2 prime equal to 0. So that gives us minus J2 I1 prime plus 2 plus J2 I2 prime equal to 0. Alright, there's the second of our two equations. Now we can solve. So solving using MATLAB. We have I1 prime is 2.4 minus J2.4, and I2 prime is 2.4. Now, if we look back at our circuit, and if we apply KVL around this loop, so if we start off, we'll get VOC is equal to the voltage across here, which is J4 I1 prime, the voltage across here, which is 6 I2 prime plus 2 VA prime. That's just doing KVL VOC, is there's no voltage here because the current is 0. J4I1 prime plus 6 I2 prime plus 2 VA prime. And if we make the substitution for VA prime, 2 VA prime, so we'll have minus J4 I1 prime minus 2 I2 prime. That's 10.73 at an angle of 63.43. Okay, now that completes our calculation of the open circuit voltage. Now we need to calculate the short circuit current. So now we're going to take our circuit, we're going to place a short between terminals A and B, and again we'll use mesh analysis. And if we notice, I short circuit will be I3 double prime. And again, if we look for our controlling variable, again, VA double prime is going to be minus 4 I2 double prime. So now we've got three equations. We got three unknowns, I1 double prime, I2 double prime, and I3 double prime. As a result, we're going to need three equations. So let's start again with the top mesh up here, and we'll have 4 I1 double prime plus J4 times I1 double prime minus I3 double prime plus J2 times I1 double prime minus I2 double prime equal 24 to angle of 0. And that reduces to 4 plus J6 I1 double prime minus J2 I2 double prime minus J4 I3 double prime equal 24 to angle of 0. So there's one of our equations. Okay, so now let's go down and let's start with this mesh. Okay, so we'll have, starting here and going around, we'll have 6 I2 double prime minus I3 double prime plus 2 VA double prime plus 4 I2 double prime plus J2 times I2 double prime minus I1 double prime equal to 0. And if we start simplifying, we'll get minus J2 I1 double prime plus 10 plus J2 I2 double prime minus 6 I3 double prime plus 2 VA double prime, and we really know that this will become minus 8 I2 double prime when we make our substitution. So this equation becomes minus J2 I1 double prime plus 2 plus J2 I2 double prime minus 6 I3 double prime equal to 0. Okay, so there's our second equation. Now we still need to do the mesh equation for this mesh. So if we start here, we'll have J4 times I3 double prime minus I1 double prime plus 3 I3 double prime minus 2 VA double prime plus 6 times I3 double prime minus I2 double prime equal to 0. And if we make the substitution into here, then our equation becomes minus J4 I1 double prime plus 2 I2 double prime plus 9 plus J4 I3 double prime equal to 0. Okay. Alright, that's 3. Now, I short circuit is just I3. Okay. So, solving using MATLAB, we get I3 double prime, which is equal to I short circuit, is 0.7511 at an angle of 69.86 degrees amps. So now we have I short circuit. Now we can calculate Z Thevenin. Okay, so we know that Z Thevenin is V open circuit divided by I short circuit. So we have 10.73, angle of 63.43, 0.7511 at an angle of 69.86. Gives us 14.2857 at an angle of minus 6.43 degrees. Now our Thevenin equivalent then is this. Now we can go in and hook our minus J2 back up and calculate V0, and we can calculate it very easily using voltage division. And V0 then becomes 1.4653, angle of minus 12.34 degrees.